A very good morning to you all, children. I welcome you all to this session of science. And in science, we are on to chemistry. We are on to the chapter carbon and its compound. And we have seen what is a carbon, why it is called a wonder element due to its properties of catenation, tetravalency, formation of covalent bonds, right? And then why carbon forms so diverse kinds of compounds. What are hydrocarbons? What is an homologous series, right? And we have seen how nomenclature of organic compounds are done, right? Now today we'll be seeing what is a catalyst. Catalysts are substances that cause a reaction to occur or proceed at a different rate without the reaction itself being affected. Now see here, the catalyst, what they do is they generally increase the rate of reaction, right, without themselves being altered. They get altered in the beginning, but when the product is formed, then these catalysts separate out, right? The catalysts separate out. Now the best example is conversion of vegetable oils, right? Right, then that process is called hydrogenation, right? Okay. Now substitution reaction. In substitution, you can see here in this reaction, right, one hydrogen from the reactant from methane is removed. See this one here, one reaction, one hydrogen has been removed, one chlorine atom gets replaces it and fits in here, right? One chlorine atom fits in here, right, and HCl is formed, right? Now let us study about ethanol. Ethanol is C2. Ethanol, the formula will be, just a minute children, the formula will be C2H5 and then OH. This is ethanol's chemical formula, right? It's a colorless, sweet smelling liquid of pungent taste. It's highly inflammable and soluble in water. Boiling point is just 78 degrees centigrade, right? And consumption of it, you all know, it causes drunkenness, right? Okay. Now reactions, combustion, it takes place with easily with air with a blue film, C3, CH3, CH2OH. With oxygen, it forms carbon dioxide, water and heat. Reaction with sodium, we get sodium ethoxide. See, this is sodium ethoxide here, C2H5ONA, from chromium trioxide. Now see here, oxidation is occurring here, and in oxidation you all know there is removal of hydrogen, and for there is a formation of acetaldehyde, or another name of acetaldehyde, it's ethanol. You can call it as ETHANAL, ethanol, right? Then from alkaline potassium permanganate, see, in the first one there was a controlled oxidation. Here there occurred a controlled oxidation, but here one step ahead is being moved and resulting in the formation of acetic acid, right, with potassium permanganate solution. Esterification, this is a very important reaction which is often asked in exams also, that when acetic acid is combined with ethyl alcohol, we get ethyl acetate ester, which has a fruity smell, right? Which is the smell which comes out from a ripe fruit like apple or maybe banana, right? You will find it where you will, when you will make this in the lab. Reaction with chlorine, um, hydrogen atom is removed, one hydrogen atom, when chlorine replaces hydrogen atoms, and ultimately we get a compound called chloral, right? In an unsaturated form, how unsaturated formation occurs, this is called dehydration, and in dehydration there is an elimination of water molecule from a compound, right? Water molecule is removed, right? Alcoholism is a regular consumption of alcohol causes dependency on alcohol, which is called alcoholism. Now what are its effect? It affects the central nervous system, it is depresses it and has an anesthetic effect. Loss of judgment, loss of emotional control, loss of moral sense, All these are its side effects, and there is a damage to vital organs. Fatty acid syndromes is there. Liver cirrhosis also occurs. Right? Now, alcohol and driving, which you all know is very, very dangerous. Effects of alcohol on driving may, because it has an effect on central nervous system, it has an hallucinating or anesthetic effect, so you may feel drowsy while driving, and that may cause accidents. The vision become blurred. So properties, now we move to ethanoic acid. Right? Ethanoic acid, another name is called glacial acetic acid. Right? It is acidic in nature, converts blue litmus reds. With sodium it forms sodium acetate. Sodium acetate, right? Now see here, with sodium bicarbonate, it causes the release of carbon dioxide. Basically, this esterification, we form ester when it is reacted with alcohol, right? And this is called saponification also, because there is a formation of soap. So, reduction, it is a strong reducing agent, right? And we use a strong reducing agent, lithium aluminum hydride, and it reduces acetic acid to ethyl alcohol. See here, reduction means basically addition of hydrogen or removal of oxygen. So in this formula of ethyl alcohol, you can find that there is a hydrogen here. There are hydrogen is how much? 4, and oxygen is 2. And in this, what is happening is hydrogen is how much? 6, and oxygen is how much? 1. Right? Okay. Now we come to soap, which are higher fatty acids, comprise of sodium palmitate, C15H31CONA, right? And this is how soap is formed, right? Glycerol tripalmitate, we take higher esters and then we make them react with sodium hydroxide to form these soaps, right? Cleansing action of soap, this is very important. A soap molecule is made up of two parts, one long hydrocarbon part and the short ionic part containing CONA group. The soap molecule is said to have a tadpole structure, which can be represented as here. The long hydrocarbon chain present in soap molecule is hydrophobic. Hydrophobic means those who uh, hate water, right? Hate water, then that is why soap molecules is insoluble in water but is soluble in oil and grease. So what happens is, when we put this soap, then oil and grease, it dissolves everything. The ionic part of the soap molecule is hydrophilic. Now when it divides into ions, then it becomes hydrophilic, then it loves water, right? Now the dirty clothes have greasy and oily substance. When treated with soap, the greasy and only dirt particles attach themselves to hydrocarbon part of the soap molecule, right? This ionic part of soap molecule, however, remains attached to water. When the dirty cloth is agitated in soap solution, the dirt particles attached to the soap molecules get washed away in water and the cloth becomes clean, right? See here in this diagram, the soap missile, it traps the dirt particle, and this is how cleaning occurs. Next we move to hard and soft water. Now soft water is one which forms rich lather with soap very quickly. Lather is jhag. And hard water is one which does not form lather very readily. The hardness is of two types: temporary due to presence of bicarbonates of calcium, and permanent due to presence of chlorides and sulfates, right? And they can be removed by the addition of zeolite, which is a zeolite process which you will be studying in next classes. So with that, we come to the end of this chapter. I hope you enjoyed it as much as I did in making it. Until we meet again, it's a goodbye.